This is the biggest animal on the planet. And this is lunch. On the menu today is a swarm of krill, tiny shrimp-like creatures that are found in every ocean on Earth. In the Southern Ocean, they are central to the entire food web. But scientists are increasingly interested in krill for another reason. They believe these little animals play a part in slowing climate breakdown. This is Life Support, a series about why the global nature crisis matters for our lives. Dr. Anna Belcher is a scientist at the British Antarctic Survey who has been tracking huge krill swarms using echo sounds.
The red colour in this acoustic image shows a really strong return due to a big krill swarm. The swarm was about 100 metres deep and 1 kilometre long, having more krill in it than the population of Spain.
She's mostly been looking at their poo, which looks like this. At the surface of the ocean, minute aquatic plants called phytoplankton take carbon out of the air through photosynthesis. Krill then eat the carbon-stuffed phytoplankton, and when they poo it out, it drops down to the deep ocean, taking the planet-warming carbon with it. And when you consider that Antarctic krill could well be the species with the highest overall mass in the oceans, that's a lot of poo. In fact, scientists estimate the amount of carbon krill transfer out of the surface ocean is equivalent to the UK's transport emissions. But krill may themselves be threatened by the changing climate. Warmer weather and melting ice is putting their habitat at risk, pushing them polewards and reducing their number of young. Krill aren't the only creatures in the ocean that could play this role. When krill, fish and other animals move up and down within the ocean, they carry some carbon to its depths, either when they breathe out, or when they poo, or when their carbon-rich bodies sink when they die. This process is called the oceanic biological carbon pump.
It's really all about how deep we can get the carbon, whether it's in carbon dioxide or whether it's in an actual particle that might make it to the seabed. And what we find is, if you get to about 1,000 metres, you're talking locked away from the atmosphere for about 1,000 years. And if we can get down to the sediment, then we're talking about millennia and geological timescales.
There is so much we don't yet know about the oceans, and about how this biological carbon pump helps to control our climate. And the deeper we go, the less we know. It's hard to do science at depths of kilometres down. Very soon, we might be mining down there. A new deep-sea mining industry wants to explore for minerals such as copper, cobalt and zinc, used in electronics like phones and laptops, and energy storage, including solar panels and electric vehicles.
It's really, I guess, one big system, and we've got to consider it from the surface to the seabed. So any pressures that we've mentioned, such as things like fishing and mining, are stuff that we have to consider and understand. And before we go and, I guess, and kind of tamper with these systems, we need to make sure we understand how sustainable it is in terms of its effect just on the numbers and the biodiversity, but also on how much carbon they might take up.
Over the next year, new rules on how this and other ocean industries operate will be negotiated through a new UN deal on the high seas. That's the vast area of the ocean that falls outside the ownership of any country, and it covers half the planet, so it really matters. More and more scientists are saying that the destruction of nature is as big a threat to humans as climate change. But of course, the truth is, it's all linked. Climate change pops up in every video in this series, and we've linked to them in the description, so you can check them out if you haven't already. Please subscribe and share this video if you think more people should know about this stuff.